What if I told you that in machine learning, a team of mediocre models can almost always outperform a single genius model? You will notice the collective answer is often remarkably accurate, even if some friends are slightly off. In machine learning, this powerful principle is known as ensemble learning. We are going to break down what it is, why it is so powerful, and the three main techniques you need to know. An ensemble method combines multiple machine learning models, often called weak learners, to create one strong learner. By combining these models, we average out their individual mistakes, leading to more robust and accurate predictions. There are three main strategies to combine these models: bagging, boosting, and stacking. Bagging stands for Bootstrap aggregating, and it works like giving students an open book exam. Each model is given a random subset of the data, and it trains independently in parallel. After training, all the models vote on the final answer, and the most famous example is the random forest algorithm. Next is boosting, where each model learns from the mistakes of the previous one in a sequential process. The algorithm pays more attention to the data points the first model got wrong, and the next model focuses on fixing these errors. The final prediction is a weighted average of all the models, and popular examples include AdaBoost and gradient boosting. Finally, we have stacking, which is like hiring a smart manager to lead your team of diverse experts. Crucially, we sample with replacement. This means when we pick a data point, we put it back so it can be picked again. We then train a separate model on each of these subsamples, and these models are trained in parallel. Finally, we aggregate their results. For a classification problem, this means we take a majority vote, and for a regression problem, we take the average. Bagging is fantastic at reducing variance and preventing overfitting. The most famous example of a bagging algorithm is the random forest. Next, we have boosting. Unlike bagging's parallel approach, boosting is sequential. First, we train a simple model on the data. This model will make some mistakes. Now we build a second model, but this time we tell it to pay extra attention to the data points that the first model got wrong. Each new model is a specialist in fixing the remaining mistakes. The final prediction is a weighted sum of all the model's predictions. Boosting is extremely powerful for reducing bias and building highly accurate models. Famous examples include AdaBoost, gradient boosting machines, and XGBoost. Finally, there is stacking, or stacked generalization. This one is like hiring a smart manager to lead your team of models. In stacking, you first train several different types of models on the same data. These are your base models. Instead of immediately voting, we take the predictions from these level 0 models and use them as the input features for a final manager model. This meta model learns how to best combine the predictions from the base models, and it then makes the final prediction. So let us recap. Bagging uses a parallel democratic approach to reduce variance. Boosting uses a sequential, error-correcting approach to reduce bias. And stacking uses a meta model to intelligently combine the predictions of diverse models. By understanding these techniques, you can build more robust, accurate, and reliable machine learning solutions. If this explanation helped clear things up, please give this video a like and subscribe to Blackboard AI for more straightforward guides to machine learning. Thanks for watching.